So looking at percents, what are percents? You can think of it with a visual here that percents are actually a ratio of a number to 100. And the symbol is the little percent. So you see percent out of 100. Ratio means you can have the colon there, the word to, or the fraction bar. So you're basically taking the amount you have divided by 100 to get your percent. So visually speaking, if you were to see this grid here, any type of visual, you would just have to say how much is the whole and then what is the part that is shaded. So for this here, if you count the boxes, you see it's 10 by 10. Well, that means 10 times 10 to find out how many total boxes in the area. So 10 times 10, length times width, that means there are 100 boxes. So this is representing the 100, the total amount possible. So what percent is shaded? Okay, well, if we know it's 10 by 10, this is 10, 20, 30, 40, 50, 60, 71. 71 boxes out of 100. That means 71% are shaded. Now, if they gave you a grid but you don't have 100, you still do the same thing. You represent it as a fraction and you convert it to basically the decimal into a percent. Okay, so what would this represent? Well, how many are the total? 1, 2, 3, 4, 5. 5 total boxes. That goes on the bottom. And then you have how many shaded? 1, 2, 3. So you have 3 out of 5 shaded. Now, what is that represented as a percent or as a fraction? Well, 3/5. What you can do is you can divide 3 by 5, and then you would get 0.60, and then convert that to a percent by timesing it by 100. Or what you can do is represent, again, your percent, since it's out of 100, as a fraction. Since the bottom number 5 can go into 100, you're making an equivalent fraction. So 5 times 20 gets you 100. So then you do 3 times 20, which gets you 60. That means if you were to look at this, you would think you can estimate and say, oh, okay, this is about halfway. So we know it's about over 50%. So we got 60 out of 100. That represents 60% of the boxes are shaded, and that looks about correct. So with this being said, there are actually mathematical equations and formulas that you can do, converting between your decimals, fractions, and your percents. And the biggest thing to look at is what are you doing with that 100? So changing percents to fractions. So the first change the percent to a fraction, you need to move the decimal twice left. Well, in order to move a decimal twice left, why? What are you actually doing? You're actually dividing by 100. Again, it's because you're taking this percent out of 100. Out of, if you ever see that in a word problem, that means division. So divide by 100, move the decimal place 2 places. Then you want to underline and look at your last digit to determine what position that is. That way you know what the denominator is, and then simplify if possible. So for example, if we were looking at 5% here, what you can do is you can take that and say, okay, if it's a whole number, it's really easy. 5% means 5 out of 100. Awesome. Now you have 5 out of 100. Well, then you ask yourself, can you simplify this? Yes, I can simplify this. 5 divided by 5 is 1, and 100 divided by 5 is 20. Okay. And again, to help, it'd be good to show what you're dividing by so that you understand and kind of learn in the method of how do we actually simplify the fraction. So at this point, this is simplified, and it's done. It's 1/20. Okay, this guy here, he's a whole number again. So let's go ahead and say, what does it mean? 48 out of 100. Okay, 48 out of is a fraction bar, 100. then you ask yourself, can you simplify this? Yes, I can. I see that 4 can go into 4, and I know that 4 quarters go into 100, so I'm going to go ahead and divide that each by 4. And then 4 goes into 4 one whole time. 4 goes into 8 two whole times. 4 goes into 100, again, quarters, so 25. At this point, I can't simplify it anymore, so I am done. All right, now this is a unique case. Notice this is a decimal, so this technically means 0.3. That means not even one whole box. That means like 30% of this tiny little box is shaded. So how do we represent that? This will take a little extra step, and this one goes more with what you're looking at up here. Okay, so that means 0.3 over 100. Okay. Now you're actually going to truly see this move the decimal 2 places. So if you were to divide this by 100 or punch into a calculator, you'll actually see that you will get 0.003. Now that you see this, now what is the place value of the last one? I'm looking at the 3. So this is the tens place, hundreds place, thousands place. That's how you know what number to put it over. 3 over 1,000, because you cannot leave it with a decimal in there. These guys didn't have decimals, so it was easy. We got to skip this step. So if you see a decimal number, you must first divide it by 100, which means move the decimal 2 places left, like this guy. Then look at the last digit, say what place value are you in, and then put it over that. So again, tens, hundreds, thousands. So I'm going to go ahead and put over 1,000. Now that I have this over 1,000, can I simplify it? No, I cannot simplify it because 3 is a prime number. So that is my final answer. So another example, this time you still have a decimal, but you have ones place, same thing. You just go ahead. Again, technically it's putting it over 100. That's why you move the decimal 2 places left. So then when you move it 2 places left here, you're going to end up getting the 0.0115. Don't forget, you want to keep those original numbers there. And since it was right here, one place was moving the decimal, so divide by 10 would make it 0.1, divide by 100 is 0.01. So you went whoop, whoop, 2 places left. All right, now you're here. Now let's look at this. Look at the last digit in your answer. What place value is he in? He's in the 10,000th place. So then you must put this number over 10,000. And then again, you have to simplify. So when you simplify this here, you're going to look at it and say, okay, what's a number that can go into both? Well, they end in 5 and 0, so I'm going to divide by 5. Divide by 5. All right, and then what you end up getting is 23 over 2,000. And 23 is a prime number, so we know that we are done, and that would be your final answer. So the next thing we can do is changing fractions to percents. So what we had just did is we went from percents to fractions, and now we're going to move backwards. The first thing you can do is look at the denominators to say, is there a factor of 100? If there's not, then you can always back up to this will always work. So remember, 5 out of 8 is technically what this says. Well, out of means division. 1 out of 3, and then 1 and 3/7. So if you were to come and do the work for this, you just have to remember it's the top name number, the numerator, divided by the denominator. So the 5 would go inside of the den, and the 8 would go on the outside. Then once you see this here, you say, okay, well, 8 cannot go into 5. So you add a 0, you put the decimal place. Then you go ahead and say, how many whole times can 8 go into 50? Because once you add the decimal place here, you had to add the 0. It can go 6 times. 6 times 8 is 48. You subtract those two numbers, so then you get 2. Again, then you have to drop down your 0, going back to simple division, and you get 20. 8 goes into 20 2 whole times. 2 times 8 is 16. Again, subtract those, you get 4. And then you add the 0 because you're going to drop down from here to get 40, and then 8 into 40 is 5. Okay, well, we're not done because it said to make it from fraction to percent. So right now we are only at a decimal. Well, in order to get that to move the decimal 2 places right, that technically means times 100. So you're doing the opposite. Before going percent to fraction, we had to divide. This time we must multiply by 100. So to multiply by 100, you'd end up moving the decimal 2 places, and then your answer would be 62.5%. Make sure you add the percent sign, because if you don't, now you understand that decimals and percents are completely different. They're different by a place value of 100. So this is 62.5%. 1/3 is one that you should memorize because that one is a repeating decimal. So if you were to divide that, you will see that you end up getting 0.33333333 repeating. Well, when you convert these guys to a percent, you want to make sure you get at least into the hundreds place. So I always like to just make sure, okay, I'm going to just put 3 of them there just to be safe. Then you times it by 100. So when you times by 100, again, that's why you end up doing this second step of moving the decimal 2 places, right? 1, 2. I would like to see that you understand why. So by writing that times 100, and then your answer is 3.33%. And a lot of times you won't see the equal sign. You'll see them put a little squiggle about, because again, you had to round. This is a non-terminating decimal. This is a repeating decimal, which means it goes on forever and ever. This guy here is 1 3/7. Well, this 1 is in the ones place. That means that's 100%. So you know right now this is going to be 100%, because anything that's in the whole number, so if it was 2, it would be 200%, 3, 300%. So we know this is 100% plus 3/7. So we have to figure out, what is this 3/7? So then you would do division. So 3 goes on the inside, 7 goes on the outside. And then at the end, we'll just sum them together. Okay, well, 3 cannot be divided by 7, so then it's 0. And you add your decimal, you add the 0 on the inside. 7 goes in here 4 times, that makes 28. And then 28 subtracted from 30 is 2. Add your 0. 7 goes into 20 2 whole times. That makes 14. And then when you subtract that, you get 6. You got to add the 0. 7 into 60 is 8 whole times. That makes 56. Notice we're getting pretty far out here, 56. And then when you subtract it, you get 4, and it would be 40. So right about here, I would go ahead and stop. And again, with percent, you know you're dividing by 100. So once you get out to the thousands place, you look at the 8. Since 8 is greater than 5, you would round up. That means that this would be 100% plus, once you get here, you would have 428, and you would have to times by 100, so 1, 2, so you would get 42.8. Okay, so now what does that mean? We actually have to sum that. So it would be 100 plus 42.8. Oops. Pen's not wanting to work. 0.8, and then your final answer is 142.8%. And again, it would be about, because we did not finish this off. This is a long going division problem. So it would be about, not equal to, because this is not 100% accurate. And that would be your answer. So again, if you ever have to convert, just don't forget, if you're going from fraction to percent, you get it to a decimal. Once you get it to a decimal, you times it by 100. That gets it there. And if you have a whole number, that's already equivalent to 100%. And then the last thing which you have already been doing is going from percent to a decimal. So if I had, let's just say 5%, and I needed to convert this to a decimal, well, in order to go from a percent to a decimal, all you're doing is putting that percent over 100, like we have done. That means division. And so technically you are moving 2 places left. Why? Because you're dividing by 100. So then it becomes 0.05. Let's try another one. 75%. Well, if you're dividing by 100, what happens? I see 2 zeros. That means 2 place values. 1, 2. So my answer here would be 0.75. What if I had like 1.5%? All right, well, if you have 1.5%, again, you're dividing by 100. 1, 2. So technically, you end up getting 0.015. Because again, you divide it by 100. And then the last thing that you might be asked to do is to compare or to order your percents, fractions, and decimals. So what you want to do is look at what is given. If you're just simply comparing two different things, for example, this 45% and 4/5, and you're supposed to say it's greater than, equal to, or less than, you can decide, do you want to convert this percent to a fraction, or would you rather convert this fraction to a percent? And so I actually prefer to go from fraction to percent. That way you're not worrying about having LCD, which is your lowest common denominator being the same. So what you do is you leave 45% alone. That just drops all the way down to the answer. Then you're only working with the 4/5, and you just do what we've been taught, converting it to a percent. So what are you doing? This is a fraction. You're going to go to a percent. Okay, so I'm looking at the 5, and I see that this 5 is actually a factor of 100. So I don't need to do 4 divided by 5. I can just go quicker and just do an equivalent fraction. So 5 times 20 gets me 100. 4 times 20 gets me 80. Now I have 80 over 100. Well, again, 80 out of 100. That means 80%. So now when I'm looking at it, I can just drop down the 80%. So I have 45% compared to 80%. Well, 45% is less than 80%. But this is not the answer. This is my work. The answer must use the original. So for the answer, it would be 45% is less than or greater than. This would be, here would be actually what? Less than 4/5, because 45% is less than 80%. So that's where you put your answer. If you had to order a bunch of them, first you want to see if you're going from less than to greater than. Again, what you would do is look at what's given and decide, do you want to put everything that's given to a percent, everything to a decimal, or everything to a fraction? For that, I would convert everything to what you have the most of. So let's just say out of 3 numbers, 2 of them are decimals. Then you only have to convert 1 of them. Once you get them to everything is the same, like this, they're all percents, they're all decimals, they're all fractions, then you can order them. But again, the answer must be just like comparing. You must use your original numbers in your answer.